Hello everyone, so welcome to another LeetCode question, and today we'll be solving length of the last word question. Okay, so let's see what the question is asking of us. So it's saying that we are given a string S and it consists of some words separated by some number of spaces, not one space, there could be many spaces. We have to return the length of the last word in the string. Okay, let's go through examples to enforce understanding of the question. So let's say we have a string S and the string looks like this: hello world, separated by a single space. So in this case, the length of the last word is 5. We have 1, 2, 3, 4 and 5 characters. So we'll return 5. Now let's see the second example. This is very interesting. We have lots of spaces here and lots of spaces in between, and some spaces here and lots of spaces in the end. So if we talk about this word moon, how many characters are there? 1, 2, 3 and 4. There are 4 characters in this word. Although we had some number of spaces in the end, the answer here would be 4. Let's go to the third example. We have Luffy, still joy boy. So we have 6 characters here in the last word, so we'll return 6. So let's go through the intuition for this problem. So if we are given a string like this, there are 2 things that we need to be worried about to calculate the length of the last word. First thing is that we have to consume all the trailing spaces, right? So whatever spaces are there in the end, we will consume it, and then we can start iterating from here till we encounter the last space, or we have exhausted the string itself, right? So we can then we can start counting the number of characters when we exhausted all or consume all the trailing spaces after the last word. Let's see how to do this. There is only one solution for this, and how we're going to do this is we will maintain right index at the end of the length of the string -1. So this is the last index of the array, right? So what we can do, we can keep checking. If it is a space, yes it is, then we will reduce it again. If is it a space, yes it is, then we reduce it again. Is it a space? Yes. So again, now we come here. At this point, my right is pointing here, but at this point this is not a space. So this means that we can start counting the length of the word, length of the last word in a string. Now when we are here, we can simply go again, reduce our index right by 1 and check if we encountered a space or we have come to the first index of the array, right? So if we had a string like this, moon, and some spaces and only like this, in this case we won't encounter a space here, but we'll come when the right will become 0, right? So we don't want to go any further back, because at -1 we will not be able to find the character index, and our program will throw an error. So while a right is still greater than or equal to 0, and this time we will start increasing our size by 1, because we have encountered 1 character, right? Again my right will come here. Let's denote it only by r. This is again not a space, so we'll increase our size by 1. So this will become 2. Again we'll come here. This is not a space, so we'll increase our size by 1. This will come 3. Again we'll come here. At this point my right is not at a space, so we'll increase our size by 1. And again my right will become here. Now we have encountered a space, so we'll break out of this loop, and we have calculated the length of the word in our size variable. Okay, now let's go through the time and space complexity. So we are just iterating from back of the string to the start of the index only once. So the time complexity is linear to the size of the string, and the space complexity is big of 1, because we are not creating any auxiliary space. Let's do the code walkthrough for this problem. So like we said, we are given a string S when we have to return the size of the last word in integer. So what we did is we created a right index that is pointing to the last index of the string, and we said we will first step is to consume trailing spaces. Okay, so this is the first step. How we are doing this? While right is greater than or equal to 0, because we don't want to try to fetch a character in a string at index negative, so that's why we have to make this check, right? So while right is greater than or equal to 0, and if this character in string S at index right is a space, we will keep reducing our right by 1. Okay, and now we are at a place where either right is -1 or we have a valid character for the last word in the right index, right? So these could be 2 cases. If it is the valid character and right is still greater than or equal to 0, okay, so what we do, we check if the character in string S at index right, if it is not a space, which means it's a valid character, we will reduce right by 1 and we'll increase size by 1. We'll keep doing this till we have right as not negative or -1, and or we have exhausted, or the character at S is a space, right? So in these cases we'll keep reducing our right by 1, increase our size by 1. So this will give us the length of the last word in the string s. So this concludes our algorithm for the question length of last word. Thank you.